carbonyl AN. Okay, carbonyl compounds. Okay, so carbonyl compounds means that compound which contains C double bond O, and the two valencies will be left over. And if this valency, one valency is alkyl group, and another one is satisfied by a hydrogen, that is aldehyde. Okay, that is becoming aldehyde. And similarly, this carbon oxygen double bond, the two valencies are satisfied by R same or R prime, right? R may be equal to R prime, or R may not be equal to R prime. Both are alkyl group. This is called as ketone. Okay. So carbonyl group means carbon oxygen double bond should be there. Okay, and later on I will tell you why this carbon. In the same chapter we will be studying about aldehyde in addition to aldehyde ketone. The third one is RCOOH, that is carboxylic acid, but it is not a carbonyl compound. Not a carbonyl compound. Why? When we discuss about the carboxylic acid, you will come to know. Very easy to understand because of some reason resonance or not. Carbonyl compound is only aldehydes and ketones. This acid is not a carbonyl compound, but some acid derivatives can be considered. That you will come to know once you understand why carboxylic acids are not carbonyl compound. You will understand. Okay. Right. So this is about the introduction part, and these two of them are acting as this ketone, and aldehyde will be acting as a functional isomers. Okay, that also remember that functional, they will exhibit functional isomerism, ketone and aldehyde. Okay, one example, just to check up this example, CH3, CH2, CHO. Right, this is aldehyde. The IUPAC name is propanal. Propanal AL will come. Okay, then another one is CH3, CO, CH3. The common name is acetone, and IUPAC name is propanone. Okay, so both of them, you see that this is C3, H6O. Is also C3H6O. Both of them are having same molecular formula, but different structure, entirely different compound. You see that aldehyde is CH3, CH2, C double bond OH. See that structure. Whereas ketone is CH3, C double bond O, CH3. Both are entirely different. IUPAC names different means they are different compound. Even structure also you see that one is C double bond O H. Here another one is C double bond O, but both the side alkyl group. Atomic connectivities are different. They are different structural formula. Molecular formula is same, and different functional group. One is aldehyde functional group, another one is ketone functional group. That is why they are coming under functional isomerism. Okay, so one isomerism exhibited by this compound you can take. Another one is regarding ketones. They can be included in the metamerism. Metamerism. Okay, what is metamerism? All of you know. Carbon oxygen double bond you take. Here CH3, CH2. Here CH2, CH3. Okay, name of this compound is pent, all A and pentane, 3 on. Now I am here writing another one, pentane, 2 on. This is CH3, CH2, CH2, C double bond O, CH3. See, both of them are metamerism. What is metamerism? See, this is one side of the functional group. This is another side of the functional group. This is one side of the functional group. This is another side of the functional group. Okay, so functional group is this one. CO is the functional group. Okay, so here there are two carbon atoms, here two carbon atoms, here three carbon atom, one carbon atom. So 2 plus 2, 4, 3 plus 1 also 4. But distribution of number of carbon atoms on either sides of the functional group. On either sides of the functional group, distribution of carbon atoms, or you can say distribution of alkyl group. Both the side ethyl, one side propyl and one side methyl. Total number of 4 carbon atoms comes, but distribution is 2 plus 2, 4 and 3 plus 1, 4. Okay, so it comes under metabolism. What is the definition of metabolism? Same molecular formula, but different structural formula, different structure, different compound due to what? Due to different distribution of carbon atoms on either sides of the functional group, on either side of the functional group. Okay, so this is also copied down. Like that, you can write many more examples. This is only metabolism is shown by only what we can say that ketones. Okay, not aldehydes. Then next one is chain isomerism, you write. This chain isomerism mainly for chain isomerism. See, I am just going for only that carbon skeleton alone. See, CHO you consider. Another one, see, CHO. You fill up the hydrogen. I am writing only carbon skeleton. Now we fill up this here hydrogen CH3, CH2, 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 CH2. This is CH3, CH3, terminal, all terminal CH3, 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 here H, here H2, H2, here H2. See, now look at the molecular formula. Total number of carbon is C6. HC5, 9, 11, 12. Whoa. You see here also 12. 9, 10, 12. Here also 12. Whoa. So molecular formula same, different structural formula. You see the IUPAC name, you see. What is this called? This is called hexane. Hexane. Hexanal, you can say, because number 1 al not required. I have told you. Again, if you want, you can write, otherwise not required. Hexanal. Okay, but this is 4-methyl. You do correctly, 4-methyl pentanal. Pentanal. This is 3,3 dimethyl butanal. See, IUPAC name different mean they are different compounds, completely different compounds. One is hexanal, another one is 4-methyl propanal, another one is 3,3 dimethyl butanal. Okay, all of them are different compounds, same molecular formula, different compound. Functional group also same. So they cannot be a functional isomer. What is different? You see, one is a carbon chain state, another one carbon chain with one branch, another one carbon chain with 2 branches. See, carbon chain is different, therefore it comes under chain isomerism. Carbon chain is different. Hydrocarbon chain. The alkyl group chain is different. Therefore, it is chain isomerism. Write down this example, you will be able to write any examples of this kind. Okay, now next is I am coming to this nomenclature slightly. I will touch upon this nomenclature. Just a reminder only. Nomenclature reminder, because you are supposed to be very thorough in this nomenclature. The first one is regarding common name. See, I will write from the first member HCHO. CH3, CHO, CH3, CH2, CHO, CH3, CH2, CH2, CH2O, right? And what is the name is? This is common name is formaldehyde. Formaldehyde. This is acetaldehyde, and this is propionaldehyde. Okay, PION, propionaldehyde, and this is BUTY, butyric acid or butyraldehyde. Okay. So in common system, what happened in that acetic acid, ICACID, acetic acid, or what is that? Propionic acid, that ICACID in acid is replaced by what is that? Aldehyde. Okay, in common system, acetic acid, acetic acid, but now you add up this acetaldehyde. Formic acid, but now you say formaldehyde. So ICACID, that the acid is removed, replaced by aldehyde in common system. Okay, so this propionaldehyde, butyraldehyde, this name you remember, you should have not come across before, so this is a common name. Right now, IUPAC name, you see that IUPAC name is, the first one, what is the IUPAC name? You write down, ethanol. Okay, no need to write 1AL for the higher numbers also, because I told you, whenever there is a CHO group, C double bond O and H. See, total valency of carbon is 4. Out of that, here 2 completed with oxygen, with hydrogen 3 over only 1 valency. So it will be going on here only. Okay, so that means that is one rule, that this carbon should be selected in the longest chain. According to IUPAC nomenclature, the carbon atom of the functional group must be selected. And another second rule is numbering, it should get the minimum number. That means you have to say 1, 2, 3, like that. That means always and every time it will be getting the number 1. In case of mono aldehyde group, okay, mono aldehyde group means it will be always getting 1. So no need to write 1 AL. You can write simply AL also. Both are correct. Right? Okay, so here it is methanol, methane on 1 carbon, AL. This is ethane, 2 carbon, ethane, AL, ethanol. This is propanol. This is butanol, pentanol. Okay, here even you can write 1 AL also, can be written, but not necessary. I told you just now, explained. So this is the IUPAC nomenclature. Right? Now a little bit ketone, simple ketone field study from the first number, and then you tell me the difference between aldehyde and ketone. See that here ketone, CH3, C double bond O, CH3, but it can be written as, it will be generally written on the board or book you will write CH3, CO. So you should know CO when you write C double bond O. Okay, so this is acetone, a very well known common name, acetone. Okay, now what is the IUPAC name? 3 carbon propanone. So propanone, here understand that, sir, why you are not writing number for the one means the double bond. You see that, I have told you last year during the nomenclature time. Once again, I just tell you, just don't forget again. See, what is the speciality about this carbonyl group in ketone and carbonyl group in aldehyde? In aldehyde, what happens, one side will be satisfied by hydrogen. So the carbon chain will be only one side. It may be any length, it can have a branch, it doesn't matter. So this is the condition for aldehyde. So because of this reason, it will be always in the terminal. And that carbon will be taken as 1. So no need to write 1 AL alone sufficient, because it is understood. IUPAC name should not have any dilemma. Any confusion should not be there. So here once it is always a terminal as per the rule number 1 and 2 of IUPAC nomenclature, that is select the longest continuous chain of carbon atom in which the functional group carbon atom is present. In that way, this carbon should be selected. Then second rule about the numbering is that functional group carbon should get the minimum possible number. But here, this is the terminal, so you start from this terminal, it will get number 1 always and every time. Okay, so 1, 2, 3, 4, 5 like that. So always it will get number 1. These are the two things by which we write, no need to write 1 AL, simply AL you can write it. Right. That is another one is ketone. You come to ketone. Ketone, both the side, not even one, both the side R. So minimum R is what? So minimum R is CH3. Here in case of aldehyde, what happens is C double bond O, one side hydrogen. So minimum is one hydrogen can be there. Here I cannot put hydrogen because if I put hydrogen, it will become aldehyde. So I have to keep the ketone as a functional group. Both the side R should be there. Minimum is this one. So this is the acetone name already given, that I can say the first member of ketone. So first member of ketone is C3. You see that? First member of ketone is C3. Here this is the first member of aldehyde. This is the first member of aldehyde, and it is having carbon 1, methanol, but here propanone, this is the first member. Okay, so that's why. Then number, I am coming to the number, now butane onwards. Butane also you will have butanone, you can write, butanone. This is correct, butanone. No numbering is required. Anybody who is thorough in this IUPAC system, you can understand. No need to again, I have to waste time in explaining this, which all we have studied. We are supposed to be thorough in class 11th itself. Anyway, just as a reminder, last 1 minute I am giving. See that the CH3, C double bond O, CH2, CH3. This is only butanol. There one more way we can write. Yes, I am writing that also because you may be having that doubt, but you will not ask question. So this is CH2, C double bond O, CH3. Now these are the butane 2 side. One is in this carbon atom, double bond is there. In the next carbon atom, double bond is there. See, rule says the carbon atom should be selected in the longest chain. Numbering this functional group carbon should get minimum 1, 2, 1, 2, 3. So it is 1, 2, 3, 4. So what is this? This is but, all single bond. See, single bond, single bond, single bond. Don't look at the side, only main chain is it. So all single bond butane. Okay, and in the second position, one ONA. Come to this example. In this example, longest chain. Select the longest chain. Numbering should be 1, 2, 3, 4. Because if you start from left side, 1, 2, 3 only it is getting. But right side, if you start 1, 2, it is getting. So this is correct. And now you write the name but, all single bond butane 2, 1. That means both the, whether it is this side or that side, you see that just to reverse the molecule. Okay, like that, reversing that upside down, you put on the horizontal, like that, this molecule you reverse, it will be, the first will become second, second will become first. That is not a new one. Chemical bonds are broken, then only it's a new molecule. Reversing and rotating and all will not be a new molecule. So what I want to say is, this 2 is not required. You can write butanone. Butanone also correct. Number not required. And from pentanone onwards, numbering will be required. Why pentanone onwards numbering is required? Because in pentanone, CO can be in the second position, CO can be in the third position also. Okay, so in case I'll just to show only pentanone alone, and after that you'll be able to write. Okay, now you take the pentanone, I take 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. One more I am writing 1, 2, 3, 4, 5. So here question is what? 1 double bond O here. Okay, and another one question is what? 1 double bond O here. Another question is 1 double bond O here. Okay, so what is the name of this? See that this name is 1, 2, 3, 4, 5. So this is pent, AN, pentane, 2, 1. What is the name of this? 1, 2, 3, 4, 5. That means pentane, 3, 1. So both are different. Pentane 2, 1, pentane 3, 1, both are different. These two are not equal, different. And here you see that longest chain. Numbering 1, 2, 3, 4 it is getting, but here 1, 2 only it is getting. So this is correct. 1, 2, 3 is correct. So that means pentane 2, 1. See this pentane 2, 1, pentane 2, 1, both are same. Because IUPAC name same means both are same compound. Means what you do is this first structure, you put it reverse. Just to put it reverse like this, automatically you will get the third name. That is why these two are one and the same. These two are one and the same. So only this pentane 2-1 and pentane 3-1, two are there, two different structural formula, different compounds. They are different compounds. Reason is that this is what is that metamerism. Is actually metamerism. We have already discussed. Right? So why number? I am explaining only nomenclature part now. Isomerism is over. But in nomenclature, remember pentane onwards numbering is required for ketone. Okay, but for aldehyde, none of them need a number because they will be always in the first position. And again, about ketone, one more thing is ketone will never be in the terminal carbon atom. Ketone will be always in the between the carbon atoms. Okay, CO group will never be in the terminal. It will be always in case of ketone. In case of ketone, the carbonyl group will be always in between the other carbon atom, in between the other carbon atoms. So remember that. Okay, don't forget. Remember that. These are the basic things should be known to you. Okay, now next I am coming to regarding this. Some examples I will give you as a homework. Just you practice whenever you are there. And this is benzene ring. This is with the CO, CH3. Benzene ring. Okay, so this is allyl phenyl ketone. Okay, so I can call it as CH3, CO, CH3. What I can say is dimethyl in common system. Dimethyl ketone. This is one naming. This is ketone, both the side dimethyl. Suppose CH3, CO, C2H5 in alphabetical order. See, so this is ethyl first, ethyl, methyl, ketone. Ethyl, methyl, ketone. Okay, so this is common system. Similarly, here see this is allyl group. Don't forget that is why I'm just to remind you I am giving this. Allyl group, this is phenyl group. This is phenyl group. So allyl alphabetical order A will come first. Allyl, phenyl, this is ketone. Allyl, phenyl, ketone. This is common system. And you have to write this structural means IUPAC name. So one, two, two, two examples I have given. Third will continue in the next page. Copy down. Write the IUPAC nomenclature of this one. Third question also. Fourth question. For examples, copy down and give a little more. Okay. So these 7 examples will be sufficient if you write correctly. It will be okay. And another 2 examples I will solve myself. Okay. Because that's a reminder I'll do. Completed. Can I clear the board? 7 examples. Name, IUPAC name you try. Okay. Right. Now, regarding this another one, this one, how will you name this company? Can anyone tell me how will you name it? If you know that IUPAC name, you just write down. Okay, so these are the 4 special examples. Before going for these examples, one thing you remember, see that AL we write for aldehyde group, AL we are writing, okay, methanol you are writing. This AL suffix, that is the secondary suffix in the complete IUPAC system. The last word, that is the last part of the IUPAC name, that is secondary suffix it will come. Then AL is used for aldehyde. Okay, so this AL for aldehyde is not always. It is only when the carbon atom of the CHO is chosen in the longest chain. Remember that. This I have told you very clearly, and in many places I have, especially in carboxylic acid also it is applicable. So the carbon atom of the functional group is, that is CHO group, is included in the longest chain. Then we will use that AL. If it is not included, the question comes, sir, we can't include also or what? Means there are situations we can't include. What is the situation? Because the rules we have to see this. Then on the board I have given 4 examples to explain that additional thing. Even that last example, that is not for the CBC, but it will be also one of the rules that will be asked in JE and all. Okay, so what is the thing? One rule is that if one same functional group comes more time, 2 times, 3 times, 4 times, same functional group comes, IUPAC rule says that, so you should not treat them differently. You should not treat them, even some sub rules and all will come. You should treat them equally. If it is possible, you have to treat them, or in the way they are existing in the company. Okay, and sometimes what happens, you may not have the root word. You see, in this case, You see, when suppose the same first example, if the first example had the first example being this one, and here Br is there, what you will write? 3 bromo benzaldehyde, because benzaldehyde is the root word for this complete what is there inside the circle. What I have enclosed, that is the root word is benzaldehyde, and the third position on bromo is there, that you add up, that's all. So third position bromo is there, and the remaining all are root word. But you see this first example, you do not have a root word with cyclohexane having CHO. Cyclohexane, no, it is not a benzene ring. Okay, so here what you have to do is you have to take it as a root word, this cyclohexane, and the numbering should be given to this carbon 1, and then 2, 3, 4, 5, 6. Okay, and now what you will write is again 3 bromo only, 3 bromo, because the CHO is still, it is a functional group. It is a functional group, it is not a substituent. So it will not come in the prefix, it will come in the suffix only. Let us see what is happening. Then 3 bromo cyclohexane. Cyclohexane, see that all single bond. Cyclohexane, that is the root word, cyclohexane, and E also I will write, and carbaldehyde. Carbaldehyde. Okay, so that if this CHO carbon atom is included in the longest chain, Al. If it is not included in the longest chain, you have to use the word carbaldehyde. Remember that. Carbaldehyde. Right? If the carbon is included, it is Al. Not included means carbaldehyde. Here it is not included, so in the first position, always first position. So otherwise you can write 1 also here. It will never be in other position. Functional group will be given the 1 number. So it is 1 carbaldehyde, or without number also you can write. Right? Okay. Then coming to the second example, just now I told you there is a functional group called benzaldehyde. Okay, this is benzaldehyde. But still I will not take it as a root word, because I rule says this is 2 CHOs are there, mean that don't treat them differently. Okay, so what you do is, if you cannot include both of them as a root word, there is no root word including these 2 carbon, so you don't exclude both of them. Don't include both of them. Exclude both of them means don't include. Now what is that? It is benzene ring, and the position you see 1, 2, 3, 4, 5, 6. So here what you write is benzene. Okay, IUPAC name benzene. In that E also you write 1, comma 3, and dicarbaldehyde. Here numbering is required because it can be 1, comma 4 also. It can be 1, comma 2 also in para position, ortho position, meta position. So 1, comma 3 dicarbaldehyde. This is the IUPAC name of this compound. 1, comma 3 dicarbaldehyde. In that E also I did not remove because D is not a vowel or vowel sound. So that E also benzene, E also there. Okay, now you do the third example. Third example, all of you can do. Fourth example, again, one new rule I told now, it should be known to you. If you are going for some company exam, you should know that. Okay, here in example number 3 and example number 4, I am going to give you a rule. Yes, a rule. There is a special rule in example number 3 and 4. Completed? Okay, I hope that you must have written that all of you should know that if one more than one, there is three are the totally, all of them cannot be selected. See, you can select one and two, and you will not select this one, or you can select this and this. Length will be same 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. 5 is the longest one. In that case, only one, two can be selected, one cannot be selected. But IUPAC rule says if it is not possible, you better you go for a straight chain where it is directly attached. Okay, so here this propane only. So root word is propane. Propane E also I am writing because it is 1 comma 2 comma 3 tricarbonyl. T is not a vowel, so T and E I am writing retaining tricarbaldehyde. Tricarbaldehyde. Okay, here you write down that IUPAC rule, that I complete IUPAC name. I have seen that if time permits, see that. Otherwise, note down here. So many such rules have been covered, which is not there in CBSE textbook. Okay.
Sir, not audible.
When now only or before also? Can you hear
Clear.
me?
Only six.
When you were telling the rule
Yes, sir.
that time, it was not audible.
I didn't speak. Sometime I didn't speak. That's why I'm telling. Audible now?
Yes, sir.
Yes, sir.
Okay, okay.
Yes, sir.
In between I was not talking much and all. Anyway, so what I want to say is that directly attached to a unbranched hydrocarbon. See, this is the unbranched hydrocarbon chain. In that unbranched hydrocarbon chain, directly attached to it, that carbon atom of the aldehyde. Carbon atom of the aldehyde directly attached to that chain. That means that chain can be taken as a root word. 1 comma 2, see 1, 2, 3, or 1, 2, 3, both same, only symmetrical structure. So 1 comma 2 comma 3, tricarbaldehyde you can do. Right? But second is another rule. The first rule is not governed by the governed in case of the next example. In next example, what is the thing is, see this CH, see this is the unbranched. Just I will make it first for you, then I will remove it. If this is the unbranched hydrocarbon, where see this carbon is directly attached, this carbon is directly attached, and this carbon is not directly attached. It through something attached. It is through somebody it is attached. Mean what rule says? Yeah, what rule says? So write on that. If it is not directly attached, it is attached through some carbon atom, then you don't bother about that. Here, no need to have pity on this particular functional group. Let it be treated separately. If they are all of them are directly, only the thing is, there is a competition. Three of you are coming directly in direct competition. You are coming, you climb means okay, reasonable. But not that through somebody, through some assistant, through by some other means you climb in. That is not fair. No need to feel pity on that. In that way only, even in IUPS, you also designed the rules. If they are directly attached, they have the rights, equal rights to climb. Yes, I am also functional group. I am also functional group. I am. But if they are linking through somebody, then they lose that eligibility. That's what IUPSC or IUPAC says. So what you do is this: you take it as a substituent, and then now you can choose this also. Longest chain, you use this carbon. This is, see the difference between the third example and fourth example. If they are directly attached, you should not touch any carbon atom. See, I have not taken this carbon. 3 carbon atom I have not taken because all of them are directly attached. In case if they are not directly attached, one is not directly attached, then that remaining 2 you include in the longest chain. So now it became bent. AN. Pentane. See, all single bond, single bond, single bond, single bond, single bond. Pentane. Okay, and E also I will write E pentane dial. I'll write even if you want to write what is the pentane 1 comma 5 dial also you can write. Understood? Pentane dial both are same according to me and IPAC name. Both are same. Some of you may use the dial alone. Some of you can use 1 comma 5 dial because it will be all in the terminal position only once longest chain is there. Now what is that here? What will come? The substituent. What is the name of this substituent? Tell me. This is formyl methyl. Okay, formyl methyl. See, this is formyl. This is suppose CH2, Cl means what it say? Chloromethyl group. It could be Br, bromomethyl group. So this is CHO is formyl. So formyl methyl group. So here formyl methyl is in which position? 1, 2, 3. So in the third position. Okay, so 3 formyl methyl. Okay, and since it is as rightly, it can be considered as a like a branch is having branch means that you can say like that inside the bracket. But since it is a functional group, this bracket is not required. Otherwise, if it is CH2Cl, it is a branch means the third carbon atom means what you write 3. Then you write chloromethyl. Okay, chloromethyl because the chloromethyl is a group name and it is attached in the third position. If the bracket is not the 3 chloro, then methyl means that in the same third position one more methyl, either the meaning will come. That is why. So branch is having again branch substituent mean that should be taken as a complex substituent. It should be same like in IUPAC name of this complex substituents. Now that we have to do inside this tetrakis and all I told you. Na, saying I will give you one more example. Not completely, that just to show that. Suppose see that one C. Okay. So here what is that? One is CH2Cl. CH2Cl. In this case, this is that 1, 2, 3, 4, 5, fifth carbon atom. So fifth carbon atom 5 means in the fifth carbon atom. What is that? You have tried to bis. You get 2 times the same substituent is the same time. Bis, but what is that? Chloromethyl. Okay, because it is a complex substituent. What is complex substituent? Branch is having branch in branch. Branch in branch or substituent in substituent. There is a side chain. In that one more side chain is there. The side chain means one more attachment is there. Means that is called branch in branch. In that case, if they are if the same thing is coming 2 times, you should use bis, not by. 3 times means tris. Tetrakis, I told you, tetrakis. These are the words. And not only that, after the name, it should be inside the parenthesis. Inside the parenthesis, you have to write. These are the things you have to use for complex branches, complex to branches or complex substituents. Remember that. Okay, so that is very important thing. So follow that. So these are all about the IUPAC nomenclature. Right now, next is itself. Many of you automatically left anyway. Next, we will be starting with that carbonyl group. Okay, so that it will be a mark for us when we start the next class. It should be carbonyl group C double bond O in ketone as well as in there is structural discussions. Structural discussion that will continue in the next class. Any doubt here? Anything you want to clarify with me? Any doubt? Any doubt? Okay, get ready for the next class. Tell me.
Thank you, sir.